Hi, my name's Tim Callahan. I'm the lead DFT engineer here in Oregon for client CPUs at Intel Corporation. Here to talk about a few of the challenges and trends that we see with DFT going forward. Efficiency is always one of our primary topics, and it's not just about efficiency of test cost and test time, though those are important. It's also about the effort and resource that we put into the DFT work, and can we meet the same schedule with the same resources on more and more complex SoCs from generation to generation. So one area that we're interested in is we spend a lot of time and effort designing and converging a TAP or IJTAG fabric at relatively high frequency for test cost, and then we duplicate a lot of that effort on the parallel scan bus at even higher frequency. So, one of the questions is, can we take some of that tap workload and maybe move it to the parallel scan bus, which enables us to maybe reduce some of our effort on the tap and overall, not add any effort to the scan bus. So that's something we're interested in. Multi-die testing will continue to be a challenge for us. It's on our roadmap now, and there's really no reason to think that's going to decrease or change in the future. And so, first time right and pattern quality is the key challenge here. If you have a single die at sort and then see that single die in the package part for testing, it's pretty easy to see how first time right is going to be pretty similar between those two. But then if you suddenly have a separate set of sacrificial bumps, possibly at sort, and then in the package part, maybe you don't even have dedicated pins for this die, and you're going to be going through another die and through pins over there. We really depend on the EDA tools to help us describe this environment and take these patterns and be able to deliver them with the same quality to post silicon as we do with the simple case. Customization is also important for us. So the backbone of our DFT is always going to be scan and memory BIST, but this SoC or that SoC is always going to require some custom DFT feature here and there. And especially when those DFT features require the bandwidth of a parallel bus. In the past, this has always meant going our own way in terms of these things, from RTL all the way down to the ATE tester, and that means pattern generation tools, debug, etc. So if we can describe some of these custom features to EDA tools in a way that we can take advantage of the existing pattern generation capabilities, that's also a huge effort savings for us. So we're interested there. As far as test port for scan, we continue to have interest in SerDes, high-speed ports like PCI Express. For the obvious reason that the packages are going to continue to shrink, and there's going to be fewer pins. In some topologies, a lot of the parallel buses may go away. So same point here about pattern quality. When we take a simpler interface and a first time right quality of those patterns, we want to be able to see that exact same performance in post silicon on these more complex SerDes I/O, and of course we heavily depend on EDA tools to help us create those high quality patterns. And finally, system level tests, see a continued role there and a growing role. It's really critical for us to meet the quality that our customers expect. And so the cost of SLT and potentially even fungibility with ATE tester patterns, potentially taking patterns from one socket to the other, if it makes sense financially, this is also something we're interested in.